Have you ever felt like you're just drowning in data? I mean, you've got spreadsheets, databases, all this information pouring in, but what does any of it actually mean? Well, before you can build those cool, complex models or find some groundbreaking insight, you have to take one absolutely crucial first step. And that's exactly what we're going to break down right now, the simple but super powerful art of exploratory data analysis. Let's dive in and see how we can turn that ocean of numbers into a clear, usable map. So here's our game plan. We're going to start with the guy who basically invented this field. Then we'll get our hands dirty. How do we actually structure our data? How do we find what's typical? And how do we figure out how spread out it is? And finally, we'll see how these simple moves are the real foundation for any deep, meaningful analysis. All right, so where did this whole idea even come from? Well, our story kicks off with one guy who thought statistics needed a complete overhaul. Meet John W. Tukey. Way back in 1962, he looked at the world of statistics and said, you know what, we're too focused on proving things. He argued that before we can jump to conclusions, we have to do something much more basic. Just look at the data, explore it, get a feel for it. He called this new science data analysis, and his big idea was that we need to understand our data first, then we can start asking complex questions. And that, right there, was the birth of what we now call exploratory data analysis, or EDA.
Okay, so Turkey says explore, but how do we even start? Well, the first thing we got to do is tame the chaos. We need to take all that raw, messy information and whip it into a shape we can actually work with. And for pretty much all of data science, that shape is what we call rectangular data. Now, don't let the term fool you. You already know what this is. It's just a spreadsheet. Think about it. Every row is one single thing, one record, one case, and every column is a piece of information, a feature about that thing. It's simple, but it's the bedrock of everything we do.
Just look at this example from some online auctions. Each row is one auction. Simple enough, and the columns tell us the story of that auction, what category it's in, the seller's rating, the price, and so on. And you can see right away we've got all kinds of different information jumbled together in here. And that brings us to these key data types. You've got your numeric data, like price. You've got categorical data, like the auction category. Then there's binary data, which is just a fancy way of saying yes or no, or 0 or 1, like in that competitive column. And finally, ordinal data, which is like a category that has an order to it. Think a 1 to 5-star rating. Now, why do we care about this? Because knowing these types is absolutely critical. It tells our software how to handle each column correctly. Okay, so our data is all neat and tidy, and we know what kinds of variables we're dealing with. So what's next? The very first question we usually ask is, for any of these features, what's a typical value? In statistics speak, this is called finding the estimate of location. And the one we all know and love is, of course, the mean, the good old average. We all learned this in school, right? Add them all up, divide by how many there are. It's easy, it's fast. But, and this is a big but, it has one major weakness. And that weakness is exactly why the median is so darn important. The median is just the number that's smack dab in the middle after you've sorted all your data from smallest to largest, and here's the magic word, it's robust. All that means is that it doesn't get pushed around by a few super high or super low values, what statisticians call outliers. So here's the showdown. The mean looks at every single data point to do its calculation. That's what makes it so sensitive to those extreme outliers. The median, on the other hand, it kind of just ignores the chaos at the ends and only cares about what's happening right in the middle. That's what makes it so robust. Think about it like this. Imagine you've got 30 people in a room and you calculate their average income. Now, a billionaire walks in. What happens? The average income shoots through the roof. It suddenly makes it look like everyone in that room is a millionaire. But the median income, it barely moves an inch because that one crazy high number doesn't change who the person in the middle is. See? The median gives you a much more honest picture of what's typical. So, we've found the center. We're done, right? Not so fast. If I told you that two cities have the exact same average temperature, would you know what to pack for a trip to either one? Absolutely not. One could be mild all year round, and the other could have scorching summers and freezing winters. The average doesn't tell the whole story. Right, so after we find the center, we need to figure out the spread. Are all the data points clustered tightly together like a swarm of bees, or are they scattered all over the place? This idea is what we call variability. And the most common way to measure this is the standard deviation. Now, the definition sounds complicated, but the idea is simple. It's basically the typical distance of any data point from the center, from the mean. But did you catch that word? Mean. Because it's based on the mean, the standard deviation has the exact same weakness. It's also super sensitive to outliers. So if the median is the robust hero to the mean, then the interquartile range, or IQR, is the robust hero to the standard deviation. The way it works is brilliant. It just ignores the extreme 25% on the bottom and the extreme 25% on the top. It focuses only on the middle 50% of the data and measures how spread out that chunk is. It gives you a sense of the spread while completely ignoring the crazy values at the end. So which one do you pick? It really all comes down to a single question. Are those extreme values, those outliers, an important part of your story, or are they just noise that's getting in the way? Your answer to that question tells you exactly which tool to grab from your toolkit. And that choice right there is really the last piece of this foundational puzzle. So let's take a step back and see how all these simple little components come together to form the essential first step toward finding some real insight. Here it is, your basic exploratory data analysis toolkit. It's just a simple 3-step recipe. Step 1, structure your data. Step 2, find a typical value, your center. Step 3, measure how spread out everything is. Seriously, almost every single data project on the planet starts right here. And this right here might be the most important takeaway of all. ADA is not about finding the final answer. It's not the end of the journey. Its whole purpose is to let you get to know your data, to understand its personality and its quirks so that you can start asking smarter, better, more interesting questions as you dig deep. So there you have it. You now have the fundamental tools for data exploration. You know how to take that first step and start separating the signal from all the noise. The only question left is what stories are hiding in your data, just waiting for you to ask.